Hey guys, so for my stats final, I chose to do a report on M&Ms. I wanted to see how many M&Ms are in a snack size bag. So I sorted them by colors. My sampling variable I chose to use was obviously the M&Ms. And the reason behind this, they're always been my favorite candy. The variable is quantitative. It has a discrete data values. That is because of the number of values is finite or countable. This is also a qualitative variable because it consists of a name where the product was purchased, which was Walmart. It's also considered nominal by categorization. This data consists of labels and therefore it is qualitative. The data is categorized and the data can be arranged in order so that this is considered nominal and ordinal. This data is quantitative because it consists of numbers representing counts or measurements. It is also discrete by resulting in accountable data. This variable consists of names and labels and not numerical values represented by counting. This is also a variable consists of names and labels and not numerical values represented in counting. This variable is also rational and nominal because it has zero natural starting point, which is ratios are also meaningful along with being categorized. My sampling method is observed by observing the data and counting and measuring specific characteristics. I did not modify my samplings or my findings in any way, therefore it's not labeled as an experiment. My sampling technique was convex sampling. I opened each package and separated them into sections and groups based on colors and then counted them out. The results were easy to get. My sampling method will help me to obtain a simple random sample of each snack size bag of M&Ms that is packaged by weight and normal consistency for packaging. Therefore, it has the same chance of being chosen to find out the different variables. I then recorded all my raw data into a StatCrunch, which I used Excel and I've copied those below. Scroll down here. So I created a table that shows frequency, relative frequency, and the cumulative frequency for the total amount of M&Ms in each package. Result 1 that I used is going to have 13 in each package. So we had 13 M&Ms in this package. The frequency was 1 and the relative frequency was 1. We had 14. The frequency in this one was 20 and the relative frequency was 1. We had 15, which the frequency was actually 19 in, and the relative frequency of 1. Those were the two highest in terms of frequency. We also had 16 in each bag. That occurred frequency of 9 times and the relative frequency of 1. 17 in the bag was frequency of 1 and a relative frequency of 1. So I used a pie chart here and copied and pasted it in here. The 13, which occurred only once, we had 2%. 17, which occurred once, was 2%. 16 was the third highest, which was 18%. 14 was actually the highest at 40%, and 15 occurred 38%. Again, we got those numbers from using the total number of M&Ms in each package. Here's a histogram I used as well, showing the frequency of 13, which occurred one time, 14, 20, 15 occurred 19 times, 16 occurred 9 times, and 17 occurred 1 time. I also have a chart column I use as well, just for show. I'll show you that real fast. Scroll through. So the measure of central tendency that describes my data would actually be mode. The reason being is that 15 shows up more frequently for how many M&Ms are in a snack size bag sample. My mode number would be 14 after looking at my frequency table. The worst depiction of central tendency for my data would be the median because 14 is not the central number of 13 through 17. Again, the numbers that we would use for that is 13, 14, 15, 16, and 17. Here's my summary stats. So the mean would be 14.78. My variance of a 0.70, standard deviation of 0.84. The median was 15, the range is 4, the min is 13, the max is 17. My Q1 would be 14, while my Q3 would be 15. And my mid-range would also be 15. Here's a box plot I used. So now I'm going to actually using confidence intervals to estimate 3 population parameters in my variable. I will be able to find the mean, the proportion of data values, and the standard deviation. The mean, the x-bar of my data is 14.78. My standard deviation is 0.8401. My range proportion is between 13 and 17. The proportion, or p hat, is 0.5, and the complementary proportion, or the q hat, is also 0.5. My first one, the confidence interval is 68%, and my upper and lower limits would be as follows. So it'd be 14.661, which is less than u, which is less than 14.899. The next one would be 0.312, which is less than p, which is less than 0.448. For the final one here, it would be 0.589, which is less than o, which is less than 0.882. So if my confidence level is 90%, my upper and lower limits would be as follows. That would be 14.581, which is less than u, which is less than 14.797. It would be 0.267, which is less than p, which is less than 0.493, and 0.521, which is less than o, which is less than 1.02. After looking at this, I'm very confident that my 90% confident interval estimate continues, or contains, not continues, the true mean. The reason being is because if the mean is the same mean for the sample mean, the probability is 0.38 for the sample proportion of 90% confidence interval. I cannot say, after looking, that the answer to number 3 would say that 90% of the population will fit within the 90% confidence interval. The proportions are not the same. I do not believe that my confidence intervals estimate and contain the actual population mean, the proportion, and or the standard deviation. The percentage rate of my sample would be 38% of the finding, 15 total M&Ms in each bag out of 50. For my next step, I went on to look for research on my sample variable, but had no luck finding any. I think if I were able to make an educated guess at how many snacks that bag of M&Ms had 15 pieces in it, out of 100, I would say 38. How did they get this? There was 50, out of 50 bags, 19 pieces had 15 pieces of M&Ms in them, so I just doubled the amount to get the 38 out of 100. The mean value would be 14.78 out of that. So the sample statistic I would be using for my mean is 14.78. Is going to be 14.661, which is less than u, which is less than 14.899. Let's see. We'll also be, the alternate hypothesis is 1 right till the test. Based on my confidence level being 0.95, the level of significance is 0.05, I will be using the t-distribution on this one instead of the z. I do not think that my population size will be affected by the testing processes. My degrees of freedom would be 99. There's the test results I was able to receive listed there. The p-value is larger than my level of significance of 0.05, so I will actually fail to reject the null hypothesis. But there is sufficient evidence to support the claim that there are 38 out of 100 bags of M&Ms that has 15, pieces within it. So I wanted to find the confidence intervals of the different packages. So 68%, we would use the 14.661, which is less than u, which is less than 14.899. For 90%, we're going to use 14.581, which is less than u, which is less than 14.797. Or 979, I'm sorry. This does not support my null hypothesis because it does not fall within my confidence interval, so I would have to reject that. For my next part of this project, I will split the 50 sample sizes into half. So I will use 25 snack size bags in 2 different baggies. The only thing I got out of that was I did notice that there was actually two different difference between two means and the standard deviation between both of those. So my alternate hypothesis causes this to be a two-tailed test, with the total from each bag being different sizes from one another. My confidence level will be 95% with a significance level of 0.05, or A equals 0.05. I am testing the standard deviation statistics, so I'll be using the F distribution on this one. My sample size will be affecting the testing processes, because I'm using the degrees of freedom, and this does not include the whole sample size. Again, here are the results. So since the p-value is less than significant level, I will have to again reject my null hypothesis. This is a significant, or there is sufficient evidence to support the claim that there is a different amount of M&Ms between the two large sacks filled with the small sacks. So while the hypothesis was rejected, there was sufficient evidence to support that claim. My confidence level interval is 95%. These are the results I was able to come up with. Since my confidence level does not include 0, this means there is a significant difference between standard deviation and two sacks of snack size M&M bags. I then wanted to find the correlation between the two variables, which I chose to use the total amount of M&Ms in each package compared to the deformities in each package. The correlation between the total amounts of M&Ms in a snack size bag and the number of deformed ones. So, my independent variable would be the total amount of M&Ms in a snack size bag, because that is the initial count, where my dependent variable would also be, would be the total of deformed M&Ms in the snack size bag, because this is dependent on the count in each bag. And here's going to be the data coming up. I used some scatter plots here to show the deformities. We'll let you look at those real fast. Here's a couple more. Again, these are with the total deformities that we used on the correlations. This is the simple regression. Here's those results that I was able to come up with. And now the p-values. The p-value is greater than 0.2351, which is actually higher than the significance level of 0.05. So I will fail to reject, and there is insufficient evidence to actually support my claim of the linear correlation as well. This means that the correlation is 3% between the total amount of M&Ms in a snack size bag and the deformities in each. So now I'm going to make the prediction. Again, that my x and y values, my x value I predicted would be 15 because of 14.78 being closer. For my y value I predicted 1 because it was 0.58 and it's again closer to 1 than 0. So in conclusion, I have realized that snack size bag of M&Ms are not evenly distributed, as most people would think, that there are different amounts in each package, with more dominant colors in each package. After doing my research, I realized in the 50 packages I used that there was actually more blue and yellow M&Ms in each one. This is to prove that things are not always as we seem that they're going to be, and you do not, and things that you expect aren't always the same.